Everyone, welcome to Cassandra Lunch number 98. We'll give everyone a couple more minutes to file. Get started soon. Hey everyone, welcome to Cassandra Lunch. We'll give everyone another minute or so to file in and we'll get started shortly. Alrighty, let's go ahead and cut the music. Hello everyone, welcome to Cassandra Lunch number 98. Today's talk is going to be on Cassandra on K3s. Today's talk is going to be given by Stefan Nikolovski, engineer here at Anant. Coordinators for this event are Rahul and myself. Sorry, I forgot to turn on my camera. If you're interested in giving a talk at Cassandra Lunch as well as our sister lunch, Data Engineers Lunch, feel free to reach out to me below, as well as if you're interested in being a sponsor for either of the events, you can reach out to me as well. And if you are looking at inviting people, feel free to share our YouTube channel as well as links to the events. You can find out links on Meetup, Eventbrite, as well as our YouTube channel, as well as our events page. We are part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Wranglers DC, or Data Engineers Lunch, falls under the umbrella of Data Wranglers DC. So if you're interested in all the various events and communities that fall under Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Cassandra Lunch? We cover everything that is, talks, and plays well with Cassandra, whether that be open source Cassandra, enterprise like DataStax, Skilla, Yugabyte, anything that's compliant with Cassandra via CQL, so like key spaces, Cosmos DB, and as well as tools in the ecosystem that play well with Cassandra or its variants or enterprise versions, such as Spark, Kafka, Airflow, NiFi we've covered, stream sets we've covered. So if you work with anything that is Cassandra or is in the ecosystem of Cassandra and interested in giving a talk here at Cassandra Lunch, feel free to drop me an email or drop a comment on the YouTube channel. We can get back to you as well. So if you're new here, also say hi, hello. Group roles, if you have a question, please do ask it, but be polite and courteous to others. If the guest speaker has preferences and when they prefer questions, they may prefer them in the at stopping points or as they're going along, they're free for questions. So the speaker will determine their preferences when they take over. This is meant to be community, so please do share what you know with us. The more you know, the more everyone will know. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some institutional and organizational sponsors. If anyone has any jobs, if they're offering or looking for a job, feel free to drop links, as well as if they have any meetups, hackathons, conferences, or classes that they would like to promote, feel free to drop links to those as well. DataStax Astra currently has a build-a-thon ongoing. I believe the third month has recently started, so I'm not sure if it's too late to join, but if you can, the top 3 winners for each round qualify to present their ideas on demo day. So there's cash and swag prizes to be able to be won for the round of April to May, as well as on demo day as well. Anant is hiring for full-time or part-time data platform operators, engineers, or architects. You can find out more at careers.anant.us. Upcoming events: data engineers lunches happen on Mondays at 12 p.m. Eastern. Cassandra lunches happen on Thursdays at 12 p.m. Eastern. We are finalizing our events for May, so we'll have those topics out as soon as possible. And all these videos are recorded and live streamed directly to YouTube. We started recording around Cassandra Lunch number 10, so everything from Cassandra Lunch number 10 all the way till right now, Cassandra Lunch 98, are available on our YouTube channel, as well as our data engineers lunches, and you can find those at youtube.com/AnantCorp. Cassandra.Link should be your number 1 resource for all things Cassandra. If you have any questions or you want to learn more about Cassandra or anything in the context of Cassandra, you can find all the articles that are hand curated by the team here at Anant at Cassandra.Link. And also one more thing we have is the Anant has released a second Apache Cassandra runbook. The second runbook is surrounding 3 common Cassandra data operations. I'll drop the link in the Zoom chat as well as the YouTube chat if you're interested. It's free, you can download it. And with that, we will pass it over to our speaker for today, Stefan.
All right, awesome. Thank you, Arpan. Okay. I'm assuming you can see my screen, everyone?
Yep.
Awesome. Right. Hi, everybody. Today, the title says Cassandra and K3s, and it is started with me working on K3s, which is a lightweight version of Kubernetes. You know, as I go through the presentation and then the demo at the end, which is not going to be that much long, extensive, but I did learn a lot of stuff around why we're using K3s, and obviously we'll discuss edge computing and something of the reason because why K3s was invented in the first time. So first of all, I'm going to talk about a little bit about edge computing. And you know, if anybody here has any experience or knows about it, feel free to jump in. So in the beginning, okay, perfect. Edge computing. What is edge computing, and why is it related to K3s? Well, first, let's kind of like dive deep into this. This is something that I recently figured out. It was just me. It was the beginning. It was just me learning about K3s, and then I kind of discovered edge computing, and it's what it's mainly used for. So I think it was really cool to know a little bit of background of what it is. So edge computing is transforming the way data is being handled, processed, and delivered from million devices around the world. In general, edge computing is a part of a distributed computing topology in which information processing is located close to the edge, where things and people produce and consume information. a little abstract way, but at its basic level, edge computing brings computation and data storage close to the devices where it's being gathered, rather than relying on central location that can be thousands of miles away. This is done so that data, especially real-time data, does not suffer latency issues that can affect an application's performance. In addition, companies can save money by having the processing done locally, reducing the amount of data that needs to be processed in a centralized or cloud-based location. Edge computing was developed due to the exponential growth of IoT, which is Internet of Things devices, in which connected to the internet for either receiving information from the cloud or delivering data back to the cloud, and many IoT devices generate enormous data during the course of their. We'll dive deep into K3s. It's just a lightweight Kubernetes version distribution for edge computing, which is the main use of it, and I'll come back to it. We'll get to it. I just want to kind of go into it before why we would use K3s. Why would we want to use a lightweight version of Kubernetes? What's the whole point of it, right? And I want to introduce edge computing, which is one of the main reasons why we use K3s. Computing. So let's say edge computing use cases. There are many different edge use cases as there are users. Everyone's arrangement will be different, but several industries have been particularly at the forefront of edge computing. Manufacturers and heavy industries use edge hardware as an enabler for delay intolerance application, keeping the processing power for things like automated coordination of heavy machinery on a factory floor close to where it's needed. The edge also provides a way for those companies to integrate IoT applications like predictive maintenance close to the machines. Similarly, agricultural users can use edge computing as a collection layer for data for a wide range of connection devices. What's edge equipment? The physical architecture of edge can be complicated, but the basic idea is that the client device is connected to a nearby edge module for more responsive processing and smoother operations. So DIYs and service options. The way an edge system is purchased and deployed can also vary widely. One on the end spectrum, a business might want to handle much of the process on their end. This would involve selecting edge devices, probably from a hardware vendor like Dell, HP, or IBM, architecting network that's kind of adequate to the needs of the use case, and buying management and analysis software capable of doing what's necessary. The benefits for many companies are cost saving, alone can be driver to deploy edge computing. Companies that initially embrace the cloud for many of their applications may have discovered that the costs in bandwidth were higher than expected and are looking to find a less expensive alternative. Edge computing might be a fit. So containers and Kubernetes with edge. Why is a good solution? It kind of goes together. Kind of like explore that option there. So containers in the ever-growing Kubernetes ecosystem now have become virtual industry standards. But last year was the first containerized officially. Containerized officially became developers' primary choice, according to the State of DevOps 2021 report. Kubernetes is among the key driving forces for enterprise transforming into digital-first business. Kubernetes continues to gain momentum and is thriving across many industries. Why is it good for edge? Containers are awesome. Again, consistent across a wide variety of infrastructure, and easy to upgrade and or replace containers. And it also has a strong ecosystem. So edge locations represent the next frontier for accelerating innovation. Kubernetes can help, right? And containerization is the logical choice for a variety of verticals and organizations, particularly with the more data generated closer to users. It's the logical next step for the multi-cloud landscape for several reasons. Cost savings acquired from eliminating the need to send data to processing to clouds or data centers, to the ease of containerizing core network infrastructure operations, User experience improvements gained due to bringing applications closer to consumers. And we're gonna get into the challenges of running Kubernetes on the edge. Again, most Kubernetes distributions don't support ARM. Kubernetes Cloud easily consumes up to 4 gigabytes of RAM, and Kubernetes wasn't built for embedded or offline management. Keep in mind that when I'm talking about the edge, this is going to be some bare metal or something offline. In most cases, it's going to be, well, most cases, people that use K3s might use something on a Raspberry Pi because it will emulate that kind of an edge sphere, right? So presenting, this is where K3s comes in handy. And what we're going to be taking a look today is in the lightweight version Kubernetes. So why is it lightweight and why do we need it? Well, it's because it's going to run on edge. It's perfect for the edge, and it's perfect for running somewhere offline on a bare metal. It is a certified Kubernetes distro built for production operations. It has a 40 megabyte binary, 512 megabytes memory consumption, single process with integrated Kubernetes master, kubelet, and container. So how does it work? So it has a server and an agent. We have the API server. It talks to the agent with a proxy, and then we have the container which controls the pods, the controller manager, scheduler, and kubelet. This is the basic outline of how it works. But the good thing about K3s is it's flexible in the way you deploy it. There's not one standard way of doing it. You can customize it and you can build it how you find fit, right? So the first setup would be the single server setup with an embedded database. So the following diagram shows an example of a cluster that has a single node K3s server with an embedded SQLite database. We have an embedded database with SQLite database. We have the agent nodes. We have the load balancer that the traffic comes in through. This is not highly available. This is not distributed. In this configuration, each node is registered to the same server node. A K3s user can manipulate Kubernetes resources by calling the K3s API on the server node. And this is how it looks like. Now, a step further is the high availability K3s server with an external database. As you can see, we have multiple server nodes and multiple agent nodes, which the user's kubectl commands go through a load balancer, and the external traffic goes to a load balancer. 2 or more server nodes and an external data store. So keep in mind that this has an external database. It doesn't have an embedded database like here. This again can provide a single point of failure, even though it says it's highly available. This database can be a point of failure. And the fixed registration in the highly available server configuration, each node must also register with the Kubernetes API by using a fixed registration address as shown in the diagram below. Now there is an like you see here, this is an embedded database of a K3s deployment with an embedded SQLite database, but it's not highly available. You can actually, there is an option to do it highly available with an embedded database, and it's called etcd. And the way it does it, the number of nodes required for failed node tolerance. We see how it works here. This is not K3s, but I think it kind of gets the point across. With that, let me see. So far, is there any questions? Okay, so the main point of making a project, and I think that most people that do projects with K3s. It's something that you're going to be doing on bare metal, and then a lot of the projects are something with a Raspberry Pi. And today I don't have a Raspberry Pi with me. I haven't had time to do that, but I'm gonna go to we're gonna spawn up Droplet on DigitalOcean, and we're gonna pretend that it's a Raspberry Pi or something like that. But first of all, I want to show you guys that you can start actually working with K3s fairly easily if you want. I think all you need to do is just use Docker to spin it up. So I already had it. So as you can see, I already have
Hey,
3
Stefan,
containers
do you
running.
mind zooming in when you get a chance?
Sorry?
Do you mind zooming in?
Oh, sorry, yeah. Okay. XD is the native Kubernetes high availability database. What standard deployment Kubernetes uses? Yep. So if you just want to quickly spin up K3s on your local machine, start working with it, you can just do it through Docker. And we, as you can see, I have spun up a master node and three other nodes. And the way you can work with it is you just execute and then select the master node, which is the server, and you can see that we can actually we can work with kubectl through Docker, but it's not really that much intuitive. It doesn't really get the point across. All you have to do is just download the K3s GitHub, and let me just link that in the chat. I'll push this to the chat. All you have to do is clone it. There's a Docker Compose file here, and you just need to change the tokens, I believe, and you're good to go. All you have to do is just Docker Compose up, it'll spin up. If you wanted to deal with 3 nodes, you can do Docker Compose up, scale, agent 3, right? And there you go, you have it. It's already running here. So looking at this, this is just for yourself if you want to kind of go through it. But in any case, let me pull up my droplet. So I spun up a droplet on DigitalOcean since I don't have a Raspberry Pi or anything here metal to work with, and I installed K3s on it and deployed the Cassandra database on it, and it's fairly simple. And we're going to use the Cassandra DataStax gas operator. And it's basically the same thing as deploying it on regular Kubernetes. So the first thing you want to do in order to spin up a K3s instance on your droplet, you would just have to you would do this command. You curl the get to K3s IO website, and you specify that it's a server, you specify the token and the cluster initialization. Now I already have it initialized, so I'm not going to do that. But the next thing you want to do is do the same thing, but instead of a server, you want to address here as an agent. So you have a one server, one agent. Then after you do that, your kubectl will be pointing to your K3s. As you can see, I have a control plane ready here, which is version 1.22.7 K3s. And the next thing you want to do is spin up Cassandra using the Cas operator. And this is pretty simple because we already have something like this. And if you guys, I'm going to link this into the chat as well. We kind of went through this. Right. So this
zoom in
is
specifically on the console. The text is small.
Oh yeah. So yeah, I forgot about it.
That's good.
Yeah. This is just the DigitalOcean console. You can actually do it from SSH, but just for this case, I decided not to do it. Anyway, this repository here, you can find an Anant repository where we deployed Cassandra using DataStax's Cas operator. It's pretty much the same thing here with the k3s. The only thing is you don't have to install, you don't have to start the Kubernetes cluster. The way you did that is just by writing the two other commands I showed you. You install the certificate manager, you set up the storage class. Now, you don't have to do this as well, because by default, when you spin up k3s, it has local path storage class. Right, so you don't have to go through the whole process of doing storage class and then changing the default one. You install the Cas operator. So I already did it because it took some time. I really didn't want to wait for, but maybe I should have done it here. So you have the Cas operator, control manager. Once you have that, you just apply the YAML file, which just deploys a Cassandra data center. You can say how many size, which is how many nodes. And we have it running up here in our DigitalOcean. In any case, if this was a multiple Raspberry Pi setup, we will have to actually control the traffic between it. So we'll have to do some networking. And I think that it's something that I might do in the future. I've been looking at it, but at this point, I'm just going to spin up one node, which is just going to be one droplet, and we're going to take a look at this. Then the next part is you deploy it, and that's it. It's fairly easy. If you want to see detailed how to do this, you can go to my other video, which I already went through installing all of this one by one. And you can see, you can just make the comparison and do it on the cloud or on your Raspberry Pi or whatever you're doing. And that's it. Basically, you have a Cassandra spun up on your DigitalOcean. So there we go. We have the version 4 of Cassandra. Now, I didn't really have time to set up Stargate, but eventually, if you would want, you can set up Stargate. And
You're still in the CQLSH terminal.
yeah. So then you can just get the port and your external IP, and instead of a cluster IP, you would make it as a load balancer, change the type. DigitalOcean will take care of the rest, and you will have a gate, a port where you can talk to your Cassandra database. So yeah, basically, shouldn't be really that hard. But again, doing it on bare metal might take a few more time, and we might run into some other problems. But yep. Yes, so that's about it. Does anybody have any questions?
Yeah, I have one question. So does K3s have limitations in terms of I guess what would be like a tipping point of when you would switch from K3s? Like, would it be easy to transition from K3s to Kubernetes? Say if you're migrating off hardware and you're going strictly to the cloud, like would that be a simple migration? Like does K3s make it easy for you to quickly switch to Kubernetes?
Um, I think no. I think it's fairly the same because it's the same thing. I think the only difference would be because K you would be able to use Helm charts for Kubernetes, where you just where here you just have to do everything by yourself. And I really don't know how you would transition from K3s to K8s, but so far that I've worked with it's the same thing, right? It's kubectl, you add pod, you add services, and me doing this, me spinning up the Cassandra in with the Cas operator, it was exactly the same as I would do in K, like in Kubernetes. So yeah, I think it wouldn't be that hard actually.
Okay, so I just did like a quick like so when you say Helm chart, is that specifically for like the Cassandra aspects or like Kubernetes in general? Because from what I see online, it looks like K3s has support for Helm. Um, so is that just the aspect of if you're migrating your Cassandra system from K3s to Kubernetes, you would need to make sure that like the Helm charts would transfer potentially?
I think so, yeah. I mean, if it works on K3s, it would work on the regular Kubernetes. I think from a regular Kubernetes going down to K3s might be an issue, but I think going to from K3s to another to like the regular Kubernetes is not going to be an issue, especially if you have the Helm charts.
Yeah, it looks like the K3s versions through. Actually, I can just drop this link in the YouTube chat and Zoom chat. So I feel like it would make sense for it to have Helm capability if it's just a lightweight version of it.
Yeah.
And then in terms of, I guess, setting it up, did you run into any issues like taking out the aspects of potentially putting it on actual hardware, like comparing it apples to apples to like your full like normal Kubernetes um, Cassandra deployment versus K3s DigitalOcean K3s deployment? Outside of the things you mentioned, were there any specific things that people should look out for when working with Cassandra and K3s?
I didn't really come into any issues that are really related to K3s. Spinning up Cassandra using the sort manager, the cast operator, I'm sorry. I did run into some issues, but I don't think they were related to K3s, so that's why I'm not going to mention them. But in any case, speeding up K3s was really just one like line of code, and it spun up. It didn't really take that much time. The rest of it was pretty much the same thing, same experience as working with Kubernetes.
Got it. Thanks.
So you mentioned K3s in relation to edge computing, and you mentioned it with like that normally be on like a Raspberry Pi. So what other devices is it suited for? Like, could you put it on a microcontroller or a phone or something?
Yeah, I mean that's a good question. I really was. Let's see. Let's find a picture here. So when I was researching it, it did show up that edge computing might be suited for a lot of factory kind of devices. We have a phone here, right? But let's say like something like a sensor or something like that that's connected to an edge server, and so that's why for the Raspberry Pis, I think people would most likely do it as a project, but in real world cases, it would be more useful in like a factory setting, if that makes sense.
Oh, Obi, you might be on mute if you were responding back.
Oh, yeah, I was saying, yeah, that makes sense.
All right.
All right. Last call. If anyone has any questions for Stefan here, for Cassandra or K3s, feel free to drop them on the YouTube real-time chat, or if you're watching this at a later point, feel free to drop comments on the comments section as well, and we'll try to get back to them as soon as we can. And if no one has any further questions, we'll go ahead and wrap up for today. Again, don't forget to check out our free second runbook for Apache Cassandra we've released. The link is in the real-time chat as well as in the Zoom chat. You can get it for free. Just fill out the form. And all these videos are recorded directly to YouTube. So if you're watching this after the fact, don't forget to like and subscribe so that way you can keep up to date, as well as turn on the notifications so that way you can get notified whenever we do go live, if you're able to catch it live as well. And with that, we'll wrap up for today. Take care.